So in this video we're looking at a core practical, preparing soluble salts. Could get a 6-mark question in this, whereby you'd be describing the steps involved in preparing the salt and explaining the significance of each step, what's actually taking place, why you're doing what you're doing. So this slide shows the method given to us by EDEXCEL for making our soluble salts. So it's worth pausing the video and reading through this just to get familiar with it. In the meantime, I'm going to point out a few things. Labelling diagrams. So obviously we've got the filter paper, we've got the filter funnel, and the solution in here is the filtrate. So that's actually going to be, I think in this example, our copper sulfate solution. Down here we've got a diagram that shows that we're heating our filtrate, so our filtrate is in the evaporating basin here, and we're heating this indirectly. So you could have this evaporating basin just sitting on the gauze on the tripod, heating it directly, but instead we've got this water bath, and it's the steam, the vapour from this water, that's heating our filtrate. So what's the reason for doing that? Can you explain that? So the answer is a reason down to safety. This indirect heating stops this evaporating too quickly and spitting. So there's a danger, so the hazard would be spitting, for the risk of that hitting somebody's skin, causing harm. Okay, so let's have a look at the first step. We've got H2SO4, and of course we'd write that as aqueous. We've got sulfuric acid dissolved in water. So your conical flasks and have your sulfuric acid in, and then that's placed into a water bath. Okay, and that water bath is at 50 degrees Celsius, and we're heating up the acid. Why are we doing that? Can you explain why you're doing that? So the idea is that the heat energy is going to make the reaction go that little bit faster when we add the other reactant, that is. So at the moment we're just getting those sulfuric acid molecules or ions moving around very quickly in our solution, so they're going to be colliding with our reactant that bit quicker. So the increase in temperature is to increase the rate of our reaction. Okay, so the next step, once our sulfuric acid has been warmed up, the next step is to add copper oxide. And obviously copper oxide, as we've learned previously, is a base, and bases are insoluble in water, and this solution here is made up mainly of water. So the copper oxide can't dissolve in the water, but what it can do is it can react with the sulfuric acid. So I asked students just to add a very small amount of our black copper oxide powder to sulfuric acid, and what they see happening in front of their very eyes is the copper oxide disappears. Now you might think that it's dissolving, but it's not. Instead it's reacting and it's making a new product. So the copper oxide powder is reacting with the sulfuric acid. They're our reactants, and if I look at our products, I can't see copper oxide on this side of the equation. I can't see any acid on this side of the equation. Products have changed. Our copper oxide is reacting with the sulfuric acid to make copper sulfate and water. So then we refer back to this. Keep repeating step C until the black powder does not disappear. This makes sure the copper oxide is in excess. So let's unpack what we mean by this. If we're adding copper oxide to sulfuric acid, how will we know when all that sulfuric acid has reacted? That's going to be a mystery to us. Well, if we keep on adding copper oxide and there's no more sulfuric acid for the copper oxide to react with, effectively what we're doing is we're adding copper oxide into this solution here. Now copper oxide's not going to dissolve in a solution of copper sulfate and water. There's no more sulfuric acid for the copper oxide to react with, and it can't dissolve in the water. So what we see the copper oxide doing is falling to the bottom of our conical flask because it's an insoluble base. So we keep on adding copper oxide until we can see it on the bottom of the conical flask. That means we've added it in excess. Why do we do it? So that we know that all the acid has been used up. So we now return our reactants into the water bath, bit of heat energy, so the reaction is working well. And what we should see is if we've added enough copper oxide, it's still sitting at the bottom of the conical flask. So the next stage of the process is filtration. So I'm going to have my product filtered. So it needs to pass through the filter paper. And what I'm going to find here is obviously my copper oxide. My insoluble base hasn't dissolved into the solution, so that's collected in the filter paper, and then we have our filtrate coming through, which is obviously our copper sulfate and water. So the filtrate is now transferred to our evaporating basin. So here we begin the process of evaporation, or one could say the process of crystallization, because what we want is the copper sulfate crystals. So this is obviously our product, and water is going to escape as a gas. So what we're doing is we're concentrating our copper sulfate, we're isolating that. So when we've evaporated about half of the water from the evaporating basin, we might want to transfer it to something else, such as a petri dish. So that lovely blue copper sulfate solution, I haven't mentioned that it's blue, but that's one of the things you'll have seen. That lovely blue copper sulfate solution can now evaporate. When it evaporates, it leaves us with copper sulfate crystals. Remember, that's an ionic lattice, so we get these fantastic crystals. I can't draw crystals, but the large blue diamond-shaped crystals. Now these crystals are nice and pure. That's what we've achieved in making this salt. If, however, the copper oxide was soluble, then we'd have little bits of copper oxide in this crystal. So the crystal would be impure. So they may ask you the purpose of using this metal base, and what's important here is that this is insoluble, so that we don't have it in our mixture of copper sulfate and water, which means when we evaporate the water we've got just copper sulfate. There's no copper oxide, making this an impure crystal. Would stop it forming well. Okay, so in this video we've described and we've explained our core practical.